So, what is faculty members? Good morning to one and all. Hello.
Sir, it's okay. Okay, present, sir.
Okay,
No.
my voice also okay.
Yeah, it's audible. No problem.
Okay, my screen also okay.
Yeah, everything is good. Present.
Okay, thank you, Das. Thank you, sir. Okay. So, welcome you one and all. I hope this is your last technical session of the 5 days program. So, thank you, Murugan sir. Murugan sir nicely organized almost all the schedules and then the events, everything. It is very nice manner he organized. And I hope that the last 4.5 days, you got a lot of ideas related with the data science. So some of them, so before joining the program, you may, some of them are maybe other discipline people also there, other background people also there. So they don't know about what is the data science, what I will have done. But nowadays, now I hope almost all the participants, you have some confidence about what is the data science, what we can do with the help of the data science, what are the scopes are there, what are the possibilities are there, where I have to start. Suppose you are going to start the research work, or if you are already in the middle of the research work also, definitely in the data science, not only the data science, definitely you studied some of the interdisciplinary field along with the data science also, definitely it will help in your future. Okay, so this session I am not taking because almost all the topics the experts may be covered. So I have to see some of the applications as well as some of the concept related to the IoT cloud, but I will give you some more deep idea about the deep learning, because nowadays deep learning will play in the emerging role. Almost your upcoming almost all the research problems we have to solve with the help of the deep learning concept. Nowadays almost the machine learning concept is somewhat obsolete, because every time whenever talking about our computer science field, computer science professor or computer science faculty, so 5 years back, everybody is saying that, sir, I know VB very well, .NET very well. So after 1 or 2 years, you see the field. So every year or every time to time or minute to minute, we have to update our knowledge, comparing with other discipline people or civil or mechanical. Other discipline, almost their concept is same, but we have our application level or our implementation level, n number of different tools are there. Language also there. So everyone, it is up to we are high. Whenever you are writing the thing, is most of the things are a new kind of things only. Okay. So coming to our topics, in the see the data science in the future will be IoT, cloud, deep learning, and the NLP. So according to my knowledge, so these are the four main concepts will play in that emerging part in the future of the data science, because nowadays most of the places we are gathered data with the help of the IoT only. So IoT will come into the picture another very soon. So everywhere we will see the most of the things are IoT enabled device, IoT TV, IoT car. So everything is the IoT based. That means a sensor based, sensor with the Wi-Fi. Then we can call it as some of the IoT device. I hope you some of the expert may share more idea about the IoT in the thing. So IoT will play similarly cloud, because we cannot able to process all the things. Is correct. I have the huge amount of data is there. If you want to process the huge amount of things, then we need the high end of the hardware as well as some software setup is required. Why should I pay for that one? So everywhere we have to switch over to the cloud concept also. Then deep learning. So deep learning in the sense analytics part, nowadays your data is not only structured part. So most of the data are nowadays it is unstructured formatted data only in the future, because our data are IoT data. So definitely the data may be unstructured data and the time series kind of data analytics means, so deep learning will help into the more picture. And the NLP means nowadays social media analytics, because I cannot always see that IoT data. I can able to process the human language data also. So that NLP will also coming into the major role of the data science. So future of the data science, if you know that deep learning, NLP, IoT, cloud will come all. It is not only one field. So it is some hybrid level of things. So all the disciplinary should be required for the data analytics. So this is the first I will start the little bit about the IoT. So today my agenda, my plan is, so first we will start 1 or 2 slide about what is the role of IoT, then what is a cloud. Then I will show some demo on the Google Cloud. I hope you may know that the Google Cloud. Anyway, I will show something about the Google Cloud. Then we will see about the deep learning. In the deep learning, there are 2 networks I am planning to. One is a CNN, another one is a RNN. One is a convolutional neural network. Another one is a recurrent neural network. So then finally at the end of the things, I will show some demo on Python about the CNN, RNN with some application oriented. Okay, that I will show the demo. So I didn't share that the coding because last presentation also sir asked to share the code. I shared the material, but I didn't share the code part. Today after the end of the session, so I will share all the coding also. Then I will share some of the books also, some of the data analytics oriented books also I will share to you. Please go through it and please practice the application things. Okay, you practice basic level. Don't straight away start with a high level program. Suppose you are beginners to the Python or the data analytics field, means you start with some basics level. So that I will share some of the books that will help you to start from the basic. Then you implement almost all kinds of application. Okay, so you see IoT in the sense that is mainly used for the your data generation is correct. If you are see the machine learning or the data science or data analytics, so that is a end level, that is a final decision taking. If I want to take some decision or if I need some prediction kind of analysis, then we go for the data science, some prediction, machine learning or deep learning. So before that we need the data. So first our input part is we need the data, where what type of data, whether I have the IoT data or I have that some database data or I have the some social media data. So that is a type of data. So nowadays I told you most of the data we are gathered with the help of some sensors, some of the IoT. So IoT will be playing almost your agriculture field or it is some the education field. So most of the things are nowadays we can say smart. Whenever we use the word smart city, smart home, smart car, smart home appliances. So that means what is the meaning that the word wherever smart is coming means automatically behind that IoT is there. Okay. So IoT data is nowadays because your first time till in the diagram. So IoT data is the time series data, because whenever we are gathered the data, one sensor is generating on the data means associated with the timestamp also. What time we are gathered the data, so the data is the timestamp data. Okay, so the data we are generating with the help of the IoT devices. Here I am mentioning some of the IoT devices. So for example, we are gathered the data from your agriculture field also. Okay, we can generate the data from the agriculture field also, or whatever the sensor, whether traffic light or whether the hospital, so or the human being or the pressure, whatever the sensor we are using. So from that we are gathered the data. Then we are gathered the data should be transmitted, because we have to process the data. So initially we are using some of the communication media. So nowadays you heard that the LoRa is the one of the powerful communication media we are using. It is nothing but it's a long range. So up to 5 km to 10 km we can transmit the data. Okay, nowadays because your IoT, your sensor is some Wi-Fi device. So we have to deploy the sensor in some the remote place. So from the remote place, in the sensor sends the data, it has to transmit it. Your processing station should be somewhat far away. So we need some long range communication medium. So nowadays most of your IoT applications we are using the LoRa. So LoRa is nothing but the long range communication Wi-Fi media. So using that we are transmitting the data. So after that we are storing into the cloud setup. So once these are the things are your data gathering part. So after that we are doing that our analysis. So then we have to analyze the data. That means using the machine learning model, we have to build the model. So that we have to use for some prediction analysis. Okay. So this is the simple setup. Normally we are using that IoT environment. So this is one of the simple project our MTech student they did it. What is the thing? It's just some prediction of the avoiding the bad attacks. I hope nowadays in the IPL match also, during the advertisement time, one girl will demo on the mobile. Have you noticed some of them? You may notice the things. Some of the bird will sit and it will disturb that, it will eat the crops and others. So from that mobile, she will make one app, it will give the alarm, it will generate one alarm, automatically the birds will flow away. I hope you may see some kind of ads. So it is also some kind of IoT based application only. Here, this is the one real time. Here in our Nagaland, we have some farmers, some remote area. We have some paddies are there. Okay, the farm lands are there. Whatever means some season, lot of different kinds of bats will come. It will completely eat taken almost all the crops. So whatever the final stage, in the final stage, it will take almost all the paddy crops and others. So we have to make that how to provide. Then our student, he went to that particular farmer. It is because one agriculture university is there. Here one agriculture university is there. So the student, he did the project along with that particular university. So what he did is he generated one alarm kind of system. So whenever the bats are coming, it is coming in a group. Okay, it is not coming one, it is coming a group of bats will come. So while it is coming, it will generate some sound. Okay, it will give some sound. So then we are the student planning that we have to using some the sound sensor. So the using the sound sensor, the range, what is the range the bats is producing the signal. So accordingly, we are using the signal, we are using the some sensor. Then we are using the, that Arduino board or ESP32 board or Raspberry board. So these are the some of the IoT platform devices are there. So using the devices, we are gathered the data. Okay. Then using the data, we process that. Then it will give some the alarm signal. It will give the some alarm signal. So whenever the signal, the range input signal is exceeding the some threshold value, accordingly you got to generate the some alarm. So high sound, some alarm sound. So accordingly, that bats are flown away. So this is we implemented, and whenever the things are happening, we implemented, we connected through the mobile apps also. We using the some GSM module, we link through the mobile apps also. So these are the some of the application we can do with the help of the your IoT platform. Okay. So this is the another one application. I will tell some of the application because actually my sir is now sir told the research challenger, but earlier according to the schedule, sir told me that some of the application oriented. So that only planned some of the applications based slide. Anyway, we can discuss at the end of the slide. We will discuss what are the recent kind of researches are going on. Any challenges also we will discuss. So this is that in our Nagaland, we are very prone to the landslide because it is a somewhat the hill area. And the hill area also, our hills are not rock based. It is a most of the, it's all only soil only, and the soil also very loose soil. So whenever we are having the continuously some 5 days, 6 days continuous rain will be there. So definitely we'll get some kind of the landslides will be there. Okay. So this is here, it is happening frequently. So we developed one small IoT based one thing, that means a landslide prediction system. Okay, so for landslide prediction, normally we have to check the soil moisture. Okay, soil moisture means whenever the soil moisture is getting the some of the loose type of things. Okay, then there's a chance, because whenever more raining, if more raining means automatically the condition of the soil will be the getting the loose. Okay, then another one is the accelerometer sensor. So that is you getting for the some vibration. Okay, or some vibrating. So because landslide means some vibration will be there. Okay, so we are using that two kind of sensor. Then we use the Arduino board. So that is landslide. Then I told you that we used the LoRa setup. LoRa means some long range. So we used some LoRa setup. That is the first diagram is that site, particular one area, land side. So this is another one is the receiving side. So we are receiving side, the same thing. We got to receive the signal. So we are using the LoRa. Then we are using the some Raspberry Pi board, some the ESP32 or Raspberry Pi board. Then we connected to the GSM module. So okay, so this is the setup. So whenever we are reading the soil moisture, normally your landslide prediction is based on the soil moisture condition. So whenever the soil moisture level is, we are keeping the three threshold values. When is the safe zone, middle zone, another one is the danger zone. So whenever the threshold value cross the danger zone value, so automatically we are getting the some alarm signal. We have to set the some alarm signal that will connected to our mobile phone. So some alert, we have to get the some alert to the mobile phone. So this kind of setup also we can do in that. This is our BTech final year student did. The first the bad attack, it is one of our MTech student did. Both the student did the project under my supervision only. Okay, so this is a landslide prediction. You see the soil setup. So this is the left hand side here. It is a soil. Soil is already we put the some of the water content. So we checked the how much the threshold value it is generating. First, initially we put that some dry soil. There's no water content. So whenever we are adding the more, we are making the loose soil condition thing. We are getting the different kind of the what is the value, the threshold value. So accordingly, we got to implement it with the mobile module also. The left hand side it is the landslide. Instead of land, we put it in the ourselfly. We created the bowl. We put some sand and soil along with the water also. So this is that ESP32 board. So here the one long term. So this is our LoRa setup. So for while we are using the laptop means for giving the battery, for giving the battery power. So this is the landslide. This setup is a landslide. So this is the receiver side. Receiver side also we are using the LoRa, and this is a Arduino board. So this is a GSM module. You see here the SIM will be there. So this is a GSM module we got. So just like that, the students implemented. They implemented successfully. So these are the things we can do with the help of some of the IoT platform. Okay, so these are some of the applications, suppose IoT based some machine learning applications for predictive analytics. So machine learning applications, most of the 90% of the applications are the predictive kind of things. So we have to do the thing about the future. So that is a predictive. So what are I am summarize some of the general thing. Other than a lot of things are there. So related with that, our society environment based, some of whether weather forecasting or rainfall prediction, landslide prediction, air pollution control. I will show the air pollution also, because nowadays everybody know that the Delhi is the one of the city majorly affected the air pollutant. More pollutant affected city is the Delhi. So a lot of research going on in particularly Delhi city. You can get to the lot of so many places. You may get the Delhi data set, air pollution data set. You can get it, and most of the things are they are implemented. Earlier they implemented the machine learning. Now they are converted into the deep learning kind of things. Okay, so these are the some of the prediction analysis we can do. And COVID-19, whether the particular COVID, that is almost it is one of the hottest topic nowadays. It is going on. COVID detection also we are using that deep learning approach, because that also I will share one Python demo file. We are using the some X-ray, because nowadays we are saying that a cough. So cough means then we are using the X-ray image as the input. So if you want to process the image kind of analytics, then deep learning is the very good. The deep learning, especially CNN, will help more for that this kind of image kind of analytic, image classification problem. Then the false positive identification, the RFID data classification problem, the smart city, smart car, so smart home appliances. So whatever the things are there, e-healthcare system, and now we are using the Arokya. Say the contact trace also. So that also we can use the get of the data. From the data we can do the some prediction analysis. So where the nearest, where how long I have escaped from the particular affected people, where they are there. So some kind of machine learning applications, some prediction kind of applications we can do with the help of. So these are the data. Here the data, most of the data are IoT based data. So why I am combining with the machine learning application? So here our input data is IoT based data. That means, so most of the upcoming machine learning or upcoming deep learning applications is our source is mostly 90% of the source of the data is based on IoT only. So IoT will play the emerging role in that upcoming your data analytics field. Okay, so this is the one-sided comparing with IoT. Then you coming to the cloud. So everybody we know that the cloud. So cloud is nothing but we are accessing some third-party service provider. So no need to do the any setup. No need to do the any setup. So it is we have to, for example, we are running the Colab. It's correct. Everybody, the last 4 days, I hope you practice the Python program in the Colab only. So have you installed the Anaconda in your machine? Nothing. We are not doing anything. Python software we didn't install our machine, but we are executing the Python program. How? With the help of the Google Cloud, the Google setup. For you need the two things important. You have the one Gmail account. Another one is a one net connection. So Gmail account and internet connection is enough. So you have to run your Google, your Python program on the top of in the cloud setup. So that means Google, they are providing the software. Google, they are providing the Python environment. The Python and using that environment, we are executing the program. So that is a cloud concept. We no need to consider anything. You see, that is the advantage of the cloud. For example, everybody in our home, we are using the electricity. Everybody we are using the electricity. How you are paying we are not doing any setup for establish the electrical, for getting the electrical power connection for power line means it is a huge process, huge investment, but we are not doing anything. So your power is automatically coming to your plug point. So whatever power you want to use, you can take it from the plug point, you use it at the month end, 1 month or 2 month end of the month. So how much your usage, accordingly we are going to pay the money. So we are not worrying about the setup or distribution. Nothing is, it is not in our part. So don't worry about the headache. It is a more over headache. Why should I put my head? Okay. So that type of situation, we have to go for the cloud. Suppose you want to do some research work in your problem. So for example, deep learning. So deep learning problem means, so already I told you, if you are planning executing the deep learning problem, your data set should be more size. Otherwise, you got to face the overfitting or underfitting problem. So for that only, if you are running the deep learning program or deep learning application means your data set should be huge data set. So if you want to run the huge data set, I have the small laptop only. I am in my laptop, for example, 4 GB RAM or minimal hardware setup only. So it will take minimum 4 or 5 days if I get the output, if I am running the same kind of setup in my laptop. So what I have to do, I will go for some third-party service provider. Lot of service providers are there. They are providing the resources. So we can use their resources and complete our function or you complete our whatever we operation. We have to process or complete our task. Then whatever we used, accordingly we will pay. So that is the concept of the cloud. So this is everybody we know that the Walmart. So Walmart is the one of the leading MNC based, the one of the corporate companies. So you see the how much data they are generating. So 2.5 petabyte data they are generating 1 hour from the almost 10 lakh customers. So that means it is a huge quantity of data. So this kind of data, if we want to process, means our normal kind of setup is not sufficient. Okay, so that only we are going for the cloud setup. And I already told you that nowadays the data are unstructured time series data. So we have the n kind of types of data we are having that. We cannot eliminate the data, and it is very difficult to understand that which data is important, which data is more not important. So it is very difficult to segregate the data also. So that only better we go for that data cloud. Okay, that type of setup. So this type of already you know that this kind of things is basics only. So whatever you we cannot whatever your demand, accordingly you have to ask them. They are providing that services. So after according to the service we can use. So no need, after using only we can pay the money. So this kind of setup normally we use for the your cloud setup. So that type of already made the platform as a service, software as a service, infrastructure as a service. So these are the term normally we'll use that in the cloud. Nowadays, in the cloud will mainly use for the data science or data in the data analytics field. Cloud will play the important role because the environment, the hardware setup as well as the software setup. So we need the different kinds of platform. So it is very difficult. Each software or each platform we have to install in our machine, and we need the huge hardware as well as the processor capacity. So it is very difficult to install or keep buy all the things because cost is also involving. So that only nowadays we are going most of the applications we are implementing in that cloud setup only. Okay, so this is the up to the cloud. So here I will show one small demo on that cloud. So I hope everybody you are knowing that the Google Cloud, if you for every it is a free account only, it is a free account. So many things are there. Amazon Web Services is there, Google Cloud also there. So another one is IBM also they are providing the cloud setups. Amazon also there, Microsoft Azure also there. So much of cloud services are there. So they are having, what is the thing? They are having a huge kind of resources are there. So it is a one kind of business. They are rendering their services, the hardware as well as the software. So whoever needed, so we have to request they provide, and according to their usage we have to use that, we have to pay the money. So just I will show a simple application, simple demo. So how to use that Google Cloud. Okay, so in you just in the Google you type it. So for that one, what is the you have to do is you will get to this window. First you have to log in the things. First you have to create. I don't know how many of them are using the Google Cloud. So if you want to use the Google Cloud, first thing is you have to they provide all your information. Important one information they are asking. What is the thing means we have to provide your credit card. Actually the thing is why they are asking the credit card details means, so nowadays most of the whenever anybody is asking your credit card number means immediately will cut the call, immediately will not further proceed the transaction, because nowadays the situation is going on like that. So most of the online fraud transactions are going on. We may daily frequently we may get sir if you want any new credit card or if you are planning to give the update your credit card. So I hope everybody you are getting the call. So here why they are the cloud Google they are asking the credit card details means actually the setup is, so whatever you want to request, so they are providing the service. Accordingly according to that we have to pay the money. Suppose once you use that resources, later suppose you are not able to pay the money means how they may get the money, amount. So it is one big question mark. So for that avoiding such a kind of situation only, credit card in the sense no need to have the account in your money. Okay, debit card and other means if you are having the account then only we can able to withdraw the money. So credit card means they can deduct the money. So for that only we have to provide the credit card details. Not only credit card, we got to scan the image of the first page of the credit card also we got to send to them. Then only they will providing the accessing. Okay, so already given, and they may deduct some the $1 or minimum amount. First they may deduct that. Okay, so once if it is providing all the details, you may get to the one account. You may get the account. For that you need the one Gmail account also there. And their important thing is, so here, so this is the screen. So this is the first page. You see free trial status. So free trial status in the sense, what is the meaning that? So they are providing 90 days free trial, 3 months free trial along with $300. They are providing $300 and 90 days. So whichever complete first until you can till that time you can use their resources in a free. So they are not charging anything. Whatever resource you want, you use, whether first the money goes to go or the date, whichever it comes first, still the period you can access their resources. So now I have the how many days are there? Till I am having the 32 days are there. Till in my account almost 17,000 rupees are there. So $300 means almost it coming 300 in the 75 or 80 rupees. It is a dollar. So we are getting almost 28,000 rupees. 28,000 rupees we can use it. Similarly, 90 days, whichever comes first. Okay, so this is the one. So I will show you that one simple demo how to use the things. Okay. Here, so whatever the service, whether I want you want to execute the IoT based service, or you want to create some machine. For example, my machine is Windows machine. Okay, my machine is Windows machine. I have to run one application. So the application is Linux based. So what normally we have to do, if my machine is that Windows based machine, I have to use that one application. I have to run one application. The application means Linux based means, so we have to go for some virtual machine concept. So on the top of your machine, we have to create on the virtual environment. So that environment we have to create, we have to install whether Ubuntu or the Redux, whatever the things we want to install, any one of the flavor of the Linux we have to install, then you can run the application. Is correct. So that is a normal thing. So here using cloud, on the top of your create the one virtual machine. We can create the one virtual machine according to the setup. I'll show you. So here you have to go to the home. Suppose if anybody having the not account means you can create. It is not a huge task. Okay. So here, home. So compute engine. So compute engine in the sense we got to create the virtual machines. We got to create the virtual machines. So virtual instance. Okay, we have to create the virtual instances. So already I created. Now I will tell simple demo how to create the things. Okay. So here we have to create the instance. If you want, this is why when suppose you have the huge hardware data is there, if you want to run the huge data, your hardware setup is very minimal. We want to create the one huge kind of setup. We want to need the huge environment. That means more RAM, more CPU kind of things means we got to go for the cloud. So because otherwise you got to pay the money. Otherwise you got to buy the things. It is very costly. So don't go with that. We got to use as some cloud environment. Okay. So here, what is the name of the instance? You have to give the name of the instance. You see here, I will come that one. Okay. This is that you see now the right hand side. I hope you can see the things. So you have this much amount of there, this setup. You see, this is the setup. So what is it is the name of the instance. Okay, which region? Normally in the region will be your cloud environment. Their resources accessing thing. They are divided into region as well as the particular zone. Okay, particular one region will be there. In the region, some of the zones are there, where you have to access the one. So first zone, then the region based. They have to distribute the resources. From which zone or which region you are going to access the resource. Okay. So what type of machine you are having? I am having the general purpose. Here you see what type of machines you want. So I want the E2. So okay, E2 is the one of the machine types. So then what is how much RAM and how much CPU you want? You see whether you want the 8 CPU, 32 GB RAM memory or 64 GB RAM memory or 128 GB RAM memory. You see I want the 32 CPU memory. You see here, if I change it the processor, because I am going to use the more higher end machine. If I are using the more resources, more processor and a more higher end machine, then you see how much amount I pay, because here the cloud setup, the amount to pay how much amount we got to pay it is monthly basis. Sorry, it is hourly basis. So 1 hour, how much hour? So 1 hour I have to pay $1. 1 hour I have to pay $1. One month I have to pay the how much amount? $783. But I don't have this money. Suppose you assume that if you are using it in 1 month, so your amount is they are giving only the free in that your 30 days only. So rest of the amount automatically they will deduct in your credit card, because already we given our credit card details to there. So no, they will send the one bill accordingly. They will deduct in your credit card account. So if you are exceeding that free trial, so if you want to use the more setup, so it is no need to keep it on. Whenever you want to run the setup, you create the setup, you run your application, then you close it. So no need to keep on for a long time. So this is accordingly we got to choose the machine, what type of machine is E2, and what type of setups you want. I don't want the high level. I don't want the some minimal setup is enough. Some 64 GB RAM. So you see how much it is there. It is very 100, less than $100 only. Amount is also less than dollar. It's per hour also. They are not charging so much of things. Okay. So this is the machine type. Then where you have to get the access, what type of services, whether you want the HTTP and HTTPS. So already you know that both the traffic, whether you want the HTTP traffic means it is not a secured one, whether you want to run the secured one or a normal size connection also. Okay, I can give the both also. Okay, then I have to give the create. Now creating the instance. Then here that it will ask the what type of OS you want, which type of OS you want. So actually earlier I didn't mention. So that also we can give that what type of, whether you want the Linux OS, so what type of OS you want. Okay. So now I will run one thing. You see instance 7s already I created. You see, so here all instance they are giving the one IP address. So 10.102.128.0.8. So here you see another one things also there, that is a SSH. Okay. So what is the meaning of the IP? Whenever actually now what is I am creating one instance, I am creating the one virtual machine. So when the virtual machine means, so each machine is connected through that particular one device. See, on the top of my machine, you have one laptop, I have one OS, that is a Windows OS. And the top of the Windows, I have created another one machine. That means that is also one of the hosts. That is also one of the, and each machine having the one IP address. So that means that is the IP address of the particular machine. You see, now I am running the things. It is a starting. Okay, within 1 minute it will. And you see here are two things they are giving. Okay, so one is the IP. Another one is a SSH. Have you heard that SSH? I think some of them, those who are the network security, those who are studied in the network security, they may are familiar with that particular term. SSH is in the secured shell. Okay, whenever if you want to connect your system with the remotely, if you want to log in, that means from your system, from your browser, you are remotely logging to the connecting to another one browser, another one machine. So both the connection should be in a secured manner. It should be in the encrypted in a secured manner means. So we are using the SSH. So SSH is nothing but the secured shell. You may study then the HTTPS. You see, so whenever you are working on the browser, the left hand side one lock will be there, one padlock will be there. So what is the meaning of the padlock? So your browser, whenever you are opening the site, for example, www.google, you are typing, the left hand side, it will give that a browser, it will give that what it will show. So HTTPS means that is it is. See, now I created the machine. One minute. You see, now you can see that it's a command $prompt. So this prompt means a Python. So that means, sorry, Linux. Now I created on top of the my machine, I have created the one virtual machine according to the hardware setup. Suppose if you want to make a more core processor, if you want to make a more type of RAM setup means you allocate and create the machine and run your application. Then you close the things. So according to whatever you are using, according to that we have to pay the money. So this is the way we have to create that, we have to run the thing. So now suppose I want to check that whether the machine is working or not. Whether the machine is created, how will you check that? Anybody having any idea? So I want to check whether the particular machine is created. What is the command we will use? When we are creating one machine, that machine is IP address, whether the machine is connected, whether the machine is created linked between my machine and another machine. When we are making the network connection, so whether the machine is connected to the particular my machine, we got to check. We got to check. Normally, what command we will use? Anybody having idea? Have you heard the ping command? So ping command is used for checking that whether the particular machine is created or not, whether the particular machine is running or not. You see, pinging, I am connecting, sending and receiving the packet. So that means that machine is connecting, that we are using that particular machine. So this is the way we have to use that. What is that? The cloud setup, when we are using the creating the one. And here you can create that your, for example, you can able to run your the Python notebook also. Here a lot of the see left hand side, you can see so much of environments are there. For example, I want to run the Python notebook. I want to run the Python notebook. For example, you want to do the natural language processing system or the cloud environment. So so much of applications are there. Here we can use that. Data flow. So the data flow, using the data flow, we can run that, open the Jupyter notebooks. You see. So you heard that Apache Beam. So using through the Apache Beam, we are connecting. It is Apache Beam is some unifying model. Using that model, we are creating the Jupyter notebook. So that also we are running on the top of the Google Cloud. So that means, so in the cloud environment, they are providing enormous services are there. Using the services, you can execute all type of, you can complete the all type of data analytics or data science according to the your requirement. For example, you are processing the NLP, or you are running the some deep learning environment. So whatever the setup processing you want to run, accordingly you have to create and run the system. So wait, it will. Okay, later we'll see. We'll continue our PPT. So I have to. So okay, so this is the what is the so far what is IoT? What is the use of IoT? So nowadays, so most of the application, most of the data we are getting from the IoT environment only. So second one is the cloud. What is the role of cloud? Why we have to use for the cloud? So I will show one simple application, simple demo about the Google Cloud. Suppose you can use the AWS also no problem, or you can use that your Microsoft Azure also no problem, because what is the need for the cloud means no need to invest more cost. Suppose nowadays your application is you have to need the more kind of hardware as well as the software requirement. Then so definitely you see some of the application if you are running, definitely you may get the result after 2-3 days later only. So why should we wait for the particular time period? So that only some other services are there, some other service providers are there. So that means that we have to get it with the help of the cloud concept. So another one thing is the deep learning. So nowadays another one application is that most emerging field in the coming to the data science is the deep learning. So what is the meaning of deep learning in the sense? Everybody know that this diagram mostly most of the, I hope already some of the expert may be discussed more about the deep learning concept. So anyway, I will tell some idea about the deep learning in the sense. So the machine learning in the sense, the first thing is earlier in my discussion also what we discussed, first we got to give the input data and the data should be pre-processing. The pre-processing we are extracting the important features. Okay, that we got to achieve with the help of the dimensional reduction techniques. Okay, after you are extracting the features, we are giving to the some machine learning model. That means the machine learning model will give for the other classification or prediction problem. So this kind of setup, this kind of steps scenario, normally we are using the machine learning. While you are coming to the deep learning, there is no need for the separate feature extraction. So everything is taken care by your deep learning, the network itself. So the network is organized such a manner. So you have to give your parties, we have to give the input data and we have to get the output of the other end. So no need to worry about the pre-process, how the data are pre-processing, what are the features are important features, everything is automatically taken care by your deep learning network concept. So that is only normally the deep learning problem, the approaches we call as a black box type of processing. That means we got to give the input data and the final output data, we got to get it that you see these two output, First one is the machine learning. I'm giving the input. So what is that? I'm asking whether it is a car or not a car. So it is saying that car. Okay, the output is car. Suppose if it is a not car means it will give the not a car. You see the deep learning, it will give some other features also. Not only it gives the output, so it is giving the along with the output, it is giving some the metadata, some description about the output also. So it is a car and what is a color, what is a model, what is a some other features. We can get it not only the output, other than the output, we can get some other features also. So these type of facilities there in the deep learning approach. So deep learning is, whenever we are talking that the deep learning, already told you. So deep learning is nothing but it is a subset of the machine learning. So machine learning is nothing but it is a subset of the AI. So everything comes under the umbrella of AI only. In the deep learning, the machine learning, variety of algorithms are there. So much of algorithms are there. Supervised learning, unsupervised learning, reinforcement learning. Each learning we are having the n number of algorithms are there. But exclusively we are using only the neural network algorithm. Only the concept of the neural network we are using. And the building some that machine learning model means that is coming and we can classify it or we have to named as a deep learning. So in the deep learning concept, we are using only the neural network. So neural network based is the origin. So neural in the sense it is our neurons. The concept is based on our neurons only. So in our brain, we are having the billions of neurons are there. So this is the simple setup of the neurons. The neurons, so the neurons is having the receive the signal external some data. Your neuron can ability of data that is using the dendrites and the internally the processing will be there. So once it process, it will pass to the next neuron. So next neuron will receive the output input from the nearby neurons and the process, and it will pass to the next neuron. So the scenario, the construction is the neuron architecture, neuron arrangement is going on like that only. The same way only our neural network also using. Okay, so each neuron, here also one node. Neuron is nothing but a node. The node will receive the data, internally will process, and it will pass to the next level. Okay, so that is the concept. You see, so this is the one simple neuron. It is one single neuron, one single node concept. So each node in the neural network having the one node means the node having that some input data, it will receive the input data. Here x1, x2, x3 are the input data. So all the input data we are associating with the weights. The link we are connecting the input data. Here your input is nothing but the features. If you are giving the input one image, if the input image is an input to that particular neural network, so the image having the features are there. The features is an input. The x1 it represents the one of the feature of the particular input image or particular input. Whatever you are giving the input, in your deep learning concept, we are calling the each input as a one of the feature of the particular input data, whether it is a image or whatever it may be. So that input is here we are representing the features. For example, here 3 features are there. So in the input is connected to the particular one node. The link is associated with the weight. The link is associated with the weight. And each that is we have to add your x1 into w1 plus x2 into w2. That means input into associated weight. We have to multiply all the times. Then we summed along with the one value that is a bias value. So okay, each node is associated with one bias. Each node is associated with the bias. And I will tell you next slide. I will tell you. So that we have to these things we have to pass to the out node. So then the end stage we have to do one more function also there, that is activation function. We have to do the one of the other function also there, that is activation function. After output of the activation function only we are getting into the output side. So that is the now input to the next neuron. So the step is going on like that only. Okay, you see, so here this diagram you will get some more idea about that. So the same one, the same existing diagram only, the x1, x2 up to xn. So these are the features input. So this is associated with the weight. So this is associated with weight, and the weight is we are summing. This is the one node. The whole diagram, the whole setup is a particular one node. You imagine that thousands of node will be there. Okay, thousands of, because your feature is 100 features you are giving. Then you imagine that how many features we have to pass to the neural network. So that amount of your node will be there. All the links are associated with the weight also. And each node having the one bias, that is a one theta value. So all the values are summed and giving to that bias, added with the bias. So that is passed to the next level. In the next level, we are using that your activation function. Okay. So what is the meaning of using a bias means? Why we are using the bias means? So bias will keep the neuron is an active. Always your neuron should be active. I will tell one small thing. Suppose your x1 to xn 0. Your all inputs are 0. What will happen? You are imagine that giving the input data, your input data, all the input data values are 0. There is no input data. So if you are multiplying the data into the 0 means we will get to the 0. Okay. So that means if all the inputs are 0 means sometimes your node will not give any output. So we have to keep our node particular neuron in always active. We are using that bias. So bias is used for keeping the neuron as an active. Okay. So this is in another one angle. It is act like as an intercept. You see, if you are giving you studied the regression line. I hope you studied the regression problem also. What is the regression line equation? Y equal to mx plus c. Okay, y equal to mx plus c. So here the m is a slope. M is a slope. X is your dependent variable, and your c is the intercept. Suppose the c is missing. Your equation is y equal to mx. Your equation is y equal to mx. What happened? If there is no c in that equation, in the regression line equation, there is a no c concept. Equation is y equal to mx means, that means we are missing, we are not considering the intercept part. We are considering only the slope part means. So the line, the regression line, if you are forming the regression line in y equal to mx, only mx means whatever the data points are crossing the origin value 0, that point only the data will be considered, because we are not considering the intercept. Is correct? We are not considering the intercept. So whatever the data points are coming the origin, some 0, that means here all the values are 0. I am telling you, if all the values are 0, that value only the considering. It will not consider that any other data. If you want to consider the other data also, we are for that only we are using the C, the component C. We are using it has to consider the other data points that are not crossing that origin point also. Your regression line should consider that type of data point also. We are using the component C. The same thing. What is that role of the C in that regression line? The same concept, the same function only we are getting in the your here the bias value. The bias will act as a one function is that it is acting the neuron is an active mode. How it is acting the mode means similarly the concept of the C. And another one thing is another one role of the bias means how the neuron will shift the output value, whether I have to shift the output left side or right side, how I have to shift the particular one node. So that is also we have to get it from that bias value. So bias is one of the important factor to keep the your neuron will be always active. So that is the role of we are using the bias. Then another one thing is, what is the meaning of weight? Why we are using the weight? The particular thing means that the image we are in all the input data, we are not considering only the features. Along with the features, we are giving that another one factor also, that is a weight. Why we are considering weight means, suppose I want to differentiate, I am giving the image, input is a dog and the cat. I am giving the image as a dog and the cat as an input image to the particular neural network model. So finally it has to predict that whether it is a dog or cat. Okay. So it will extract the features. It extract the features. So among all the features, some of the features only give more weightage for deciding predicting the output. Is correct? Suppose you see color and the shape. You see that only the two features are there, shape and color. So these two features I am going to use to predict that whether the particular object is cat or dog. So among whether both the features are same, I cannot treat the color as well as the shape is not equal, because color, cat also having white color, dog also having white color. But the shape, you see the shape, some of the shape will give that final impact of predicting that or deciding that whether the particular image is cat or dog. So that only, so we have to differentiate the weight. So that means we have to differentiate the features. We have to give some importance to the particular features. So for that only we are using that the weight as one of the parameter. For example, today evening you have an appointment. Already you planned one appointment is there. Okay, evening you are going to meet your friend. So suddenly your principal calling. Please come and meet the same time. So both are same appointment, same time. You are also going to meet your friend 4 o'clock. Your principal also asked me to come and meet me 4 o'clock. Both are same. Both the values are same. So then what to do? So definitely you have to give the first priority to your principal calling only. So that is more weightage. So both are time at the 4 o'clock only, same time only. If you want to differentiate among these two input, if you want to differentiate, your model has to predict that your model, you are giving these two input as your model. Okay. meet the principal 4 o'clock, meet your friend 4 o'clock. So finally the model will say that your appointment is whether principal or your friend. How it will give the output, because both are the same value. So if you are giving more weightage to the principal call, then the model will finally give the suggestion about that. Okay, you have an appointment, you have to go meet with your principal only. Okay, so for that reason only, we are using that weight is associated along with all the input features. So and the last one is that what is the activation function? So activation function is nothing but what is the output of the particular node, how we have to activate it. So what is the output? We are giving all the input data and summed all together. So we are giving only, you see, what is the input of your activation function? Only one value. Input, you are having the 100 features or 1000 features. All the 1000 features we are multiplied with weight and we added with the bias value, all the processing, and we are giving only one input, only one digit, one input data only we are giving as our activation function. That input data, how the node will behave. So that means that output is, it reflects all your input features. That means how you are going to activate your node, how you are going to activate the particular neuron. So that is decided by the activation function. So activation function will play the major role because that is output. Your activation function output is the output of the particular node or output of the particular neuron. So that is give the more impact of the your decision, final output. That is a final output. So we have to use exactly the whatever requirement is there, accordingly we have to use the activation function. Some of the activation functions are there. I will tell some lot of things are there, but mostly we have to use the 3-4 activation function. Mostly we will use some of the application. So you see, so these are the some of the input data. We have the running out of time. So I will share the things also. So this is the input data. So this is output. So this is a one function. For example, this is a sigmoid function. This is a formula of the sigmoid function. Okay. If I am giving the j as the input, it will give the what is the j, output j. Okay. So it is a further one I am mentioning here. The output is depends upon the output of the activation function used. What type of activation function? Then some other parameter also here I am using. What is here the parameter means? So you had that the neural network, the neural network concept we are implementing is a mission based. That first neural network normally we call it as artificial neural network. You may have that ANN. So ANN is the base for your neural network. Almost all our neural network concept we are used to base is the ANN, artificial neural network. So what is the model? Actually, you see, when we are building the machine learning model also, I built the model using some of the training data. Then I have to test the model. So if the model is not giving the my expected outputs, I have to get the output 1. The model is giving 0. Then what we have to do? Again we have to train the model. Is it correct? Actually, our intention is we have to build the model. The model has to give the correct output whenever it has seen some new data. Seen the new data without label. So your model will give that correct label. Okay, so that is the aim of the building the model. Here, our machine learning approaches, if the model is not giving the proper output means we have to train the model. Using the training data, again we got to train the model. Again using the testing data, we are testing the model. Here, how you are training the model means we are adjusting the weights. Two things we have to adjust. One is the adjusting the weight. Another one is we have to adjust the bias value. So we are, because input features, I am giving the input feature. Finally, I am getting the expected or output. If I am not getting the expected output means I have to adjust the internal processing. What I have to adjust means I have to adjust the weight. We have to adjust the weight along with the theta value. So these two value I have to adjust. Okay. So the adjustment, how the adjustment will do. So at the last, for example, I am in the K node start with, for example, A, next level B, next C, D, it is going on, then I, J, K. So K is my output node. You imagine that K is my output node. So before that I have what are the nodes are there. In between I cross, in between I cross the sum of the neurons. I crossed A neuron, I passed to the B neuron to C, C to D, D to E, E to F, then I, J, K. So K is my final output neuron, last output neuron. I check the output of the particular kth neuron. It is not correct. So it is not correct. So then what I have to do? I have to adjust the weight. How I will adjust the weight and the theta value? From the last to, I have to traverse. From the last to, I have traversed towards the backward to the first. So first I got to start with the jth node, correct? Because I am getting the kth node, output node is giving the error. So first I got to adjust the j node because j is the before the next level. So then I got to, after I adjusted the j node, I got to adjust the ith node. Then I got to go with the towards the back end. So that means your correction is we have to process back way. So that type of processing, you may have that it is a back propagation. Your neural network concept, we got to adjust the weight and theta, and what basis means using the back propagation method. That means you are the k is that here I mentioned that the wjk. What is the meaning of wjk? Your kth node to jth node the weight. So all the links are associated with it here, because now error j. What is the meaning of error j? I am going to adjust the error of the jth node. If I am going to adjust the error of the jth node means, so before next one node is there. So from that link, I have to first get the weight. What is the weight of the particular node? So then what is the earlier output of the node? Here output of j. One is that, one is the your expected output. One is the expected output. So what is the your output you are getting? Zero already what output it produced. So accordingly, you got to substitute all the values. Then you have to adjust the error of the particular node. You have to calculate the error. We are not adjusting the error. We are calculating the error. So what we got adjusted? We are going to adjust the weight and the theta. In each node having the weight and each node having the theta, the weight and the theta is adjusting. For that only we are calculating the error. So this is the formula for error. The process is always we are doing from the backward to the towards. It is that process normally we called as the back propagation. So here one more parameter I am using L. So L is nothing but the learning rate. L is nothing but it is the learning rate. So we have to actually we have to train the model. We have to train the model. For training the model, so that model should not struck in between. So already I hope you heard the one term local minimum and local maximum. So what is the meaning of local maximum? So whenever I am getting the output, I think in the data structure you had our algorithm, you studied the one hill climbing search in the problem. You may study the graph. In the graph, you may see that local minima problem or local maxima problem. What is the local maxima means? Finally, I have one goal is there. So finally, I have to get one output. So in between some, I am getting one output. After that, it is going there towards a down. So that means the model may think that, okay, you have to reach the maximum, because after the maximum, you are getting your value is getting down. But definitely another one where you have the one maximum, your goal will be there. But you cannot able to stop that once you reach the local maximum value. To avoiding that kind of situation only, we are using the learning rate. So learning rate is the value between 0 to 1 only. So this is the use of that. This is the base. This diagram, whatever I am explaining thing. So this is the concept of the one neural network, how the neural network will processing. Okay. So now, and here one more important thing, your layers are organized as the input layer, then the hidden layer and the output layer. So input layer is the work of the input layer is just to pass the input node to the next node. In the hidden layer and the output layer only all the processings are there. We are extracting the features, we are adjusting the weight, everything will be done. All the processing are we are going to execute only the your in between layers only. In between layers normally we call as the hidden layers and the output layers. So there only we are processing all the things. Okay. So your input node just to pass, just to receive the input and pass to the next node. Okay. So the activation function already told you. So what is the use of the activation function? So it will determine that what is the output of the particular network. So particular, you have the one node. The node, what is the node of the output is decided with the help of the activation function only. So the activation function normally will use the hidden layer and the output layer. Your input layer is there is no processing. Input layer just we got to pass the value from your input data to the next level. Okay. So these are the 4 activation function normally we are using. One is the step function, sigmoid function, tanh function. Another one is the ReLU. ReLU nothing but a rectified linear unit. Okay. So if I am using the step function, actually what is the thing means? Here X is your input. F is your activation function. So F is your activation function. Your activation function is a step function. Your activation function is a step function. When it will give 0, whenever it is a step, whether it will give 0 or 1. Okay. There is no in between result. The node always giving the value either. So what that means, whenever you are giving the input data, in the input data, how the neuron output you have to get. I want to get only the 0 or 1 only. So whatever my input, according to the input data, once till 0, I will get 0. Whenever I am getting above 0.1 also, or 0.2 also, or 0.3 also, your activation function, that means the neuron node output of the neuron, you may get to the 1. If you are defining the step function as activation function. Okay, this is according to your requirement. So I activate my neuron. So whenever the neuron get to the value above 0, up to 0, the neuron I can say that my neuron will give the value 0 only. So when the neuron is getting 0.1, above 0.1, it crossed above 0. So after Whatever the value, always my neuron has to give 1. So that is your requirement. That is your plan means, then you have to use the step function. You can use any one of the step function according to our requirement, that when we are designing, when we are constructing the neural network model. So we have to define the activation function. What type of activation function I have to use in the neuron? So whether you are using that step function, or you can use the activation function, sorry, the sigmoid function or tanh function. So depends upon our. So this is the sigmoid function. So in the example also I am giving that. So most of the application, the image classification, most of the problem, we are using that the sigmoid function. You see the sigmoid function. What is the sigmoid function output? The output is 0 to 1. The output is, you see, left hand side is the output, right hand, the x-axis is the your input data. You can understand the logic. So here is the input data. So in the input data, maybe minus also there, plus also there. So your output, the sigmoid function output is always in the value between 0 to 1. So whatever you are decreasing the value also, it always gives 0. So whatever you are increasing the value towards, whatever the n number of values you are increasing, it will always give that 1 only. So the value is 0 to 1. If your input is 0, what is output? Your output is 0.5. Is correct. So whenever the value is minus, you see that it is just like a, what is the meaning of here means, in the step function 0 to 1 only. See, it is a step. There is no in between value. It's a straight jump. It is jump. What basis of jump? Either 0 or 1. Direct jump. I don't want the stepwise. I need the sigmoid means sine wave function. So it is not a step. I don't want the step type of output. So I don't want the sinusoidal way of output means. So whenever it is going, you see -8, -6, minus. So once it cross to suppose -4 some value, the neuron, it will, the output is your activation neuron is getting activation. It is started with the 0, 0 point something is there. So whenever your input is getting 0, the output is 0.5. So whenever you are getting values increasing, suppose your output also slightly increasing. So once you do some threshold value, we are defining some value. So for example, you see after the 6, after whatever your value will be there, your value is giving the exactly the same output. So this is the formula 1 by 1 plus e power minus x. So whatever your x is the value is there, you may get to the value. So this is the activation function. So most of the application we are using the sigmoid function also. Tanh function, your CNN network, in the CNN network, we are using that sigmoid function, whereas your RNN network, recurrent neural network, so most of the times we are using that tanh function only. Okay, so what is the use of the tanh function? You see, it is a green. So what is the earlier one output? The output of the the output of that your sigmoid function is 0 to 1. The output of the function is 0 to 1. Suppose I want to get the output to -1 to +1. You see the green color. Here the green color is the tanh function, whereas the sigmoid almost the same. Almost your sigmoid and then the formula is same. You see here 1 by 1 plus e power minus x. Here 2 by 2 1 plus e power minus 2x. Okay, it is a shifted version of your sigmoid function. Here you see the output. The output of your tanh function is -1 to +1. So whenever you are getting the value 0, that time also your output is 0. So whenever you are value getting the positive, that means when the neuron will active, whenever your neuron is crossing the 0 value, then only the neuron will give the positive value. So before that it will give the negative values. Suppose whenever you need some of the negative kind of output also, your neuron has to give negative kind of output also, then you can use the tanh function. Here what is output? It is in -1 to +1. Suppose whenever you want to don't consider some of the features, then we have to multiply that feature with -1. Okay, we have to multiply the output is we are getting -1. So -1 to that feature particular value, the value will be changed. Okay, so we will get the minus value. Whenever your application requires such a kind of requirements means, so we have to use the tanh. So what is the meaning of this? So this is the output we are getting to the particular neuron. When you are defining the tanh as an activation function, then the activation particular neuron, you may get the output in the range of -1 to +1. So that is one. So another one is the ReLU. So it is also normally mostly we will use in the CNN network. CNN mostly will use the ReLU and the sigmoid function. So sigmoid, similarly ReLU will use that it is depends upon us whatever the application. Here the thing is that you see how the function it is behave means. So it will take the value max of 0 or x. So till the 0 value, you see till the 0 value your output is 0 only. What is that your input? If the input is -1, 0, it will consider only 0, or -10, 0, it will consider only the 0. That means the output is that maximum of 0, what is the input, that value. So that is a rectified linear unit. After that, So whenever you are giving that value, so that value come out the maximum value. So that is output. So after 0 only, the neuron will be activated. So till the neuron 0, whatever your value is there, the output is always giving 0. Whatever your output values are there, the value is always giving 0. So after 0 only, the particular neuron will be activated. So this is your RELU function. Okay. So these are the mostly activation function we will use in that your neural network. I hope now you understand the concept. What is a neural network? What is the input data? What is the input is features? So why we are using the weight, and what is the requirement for the bias value? If you are not using the bias, what happen? What is the need for bias? What is the need for the weight? And what is the role of the activation function in the each neuron? What are the various types of activation function we are using in that particular neuron? We can use any one of the activation function. That is depends upon our requirement. If you that is our option. How I want to activate the neuron? How I want to behave the neuron? So according to the activation function, in the neuron will behave. What type of activation function you are giving, that type of output, according to the activation function, it will produce the output. Okay. So here, why we are calling it as a deep learning means, so deep learning means we have to extract the features. Because earlier, your machine learning concept, we are separately applying the PCA, or you are separately applying any one of the dimensional feature extraction method to extract the features. Is it correct? If you are extracting by some other algorithm, sometimes you may miss the some of the features. We don't know which of the features are important, or we don't know which of the features are less important. Sometimes there's a chances. So for that avoided another concept of feature extraction, everything is done by that your layers, your hidden layer internally to extract the features. If you are using that more number of layers, if you are using the more number of hidden layers, it will go deeply. Why it is called deep learning? It will go deep level. It will extract the all level of the your features, intrinsic level features. It will extract. So that only we are calling is the deep learning. So that why it is some problem is there. Whenever your data set is a small data set, then there is a problem for the overfitting. So whenever you are planning to define a deep learning network model, so you keep it in mind that you have to use your data set input should be more. Then definitely one question you may ask, sir, how many neurons I have to use in the hidden layer? Actually, your input layer, hidden layer, another one is the output layer. So how many neurons we have to use that layer? So input layer is nothing but it is used for receive the data. So output layer is nothing but how many output you want. Suppose I want to predict that numerical digital problem. Okay, I want to predict the number. I have to give the input is one of the hand digits. Any one of the hand digit as an input to the particular neural network. In the neural network, finally it will predict their output, whether it is a 0 or 1, 2, 3 like that. Suppose this is my problem means how many output node is required? So we need the 10 output nodes because it has to say the number either 0 or 1 or 2, 3, 4, 9 up to 9. So we need the output layer. How many output layer? 10 output node is required. So your output layer is nothing but the how many classifier, how many output is the node in the neuron in the neural network has to predict. So that is our output layer. Input layer is nothing but the how many features you want to. So in between the how many hidden layer if you want to use means that is one thumb rule is there. So the number of neurons in the hidden layer should be between the range of number of neurons in the input layer and output layer. So it is in between the range only. So if you are using 2/3 of part only. So you can use, it is our option only. We can define any one of the number of neurons only. If you are adding more, then what is the issue will come in the complexity, computation time will be more, because whenever you are doing the research, some problem, research work means, so finally we got to prove that my algorithm is, the model is giving that it is computation time is less. So that is also one of the parameter. Okay. So we have to consider that computation time also. If you are increasing more number of layers, some computation issue will come. If you are less number of input layer means you cannot able to extract the all type of features. So that means somewhere we can say it is a just kind of the some probability kind of things only. Okay, somewhere they are saying that it's just like some probability kind of things only, but the standard they are defining what type of how many standard input the hidden layers we can use for the problem. And why? What is the role of mainly the deep learning in the sense it is mainly considered for the non-linear separable problem. So whenever, what is the meaning of linear separable and non-linear separable mean? For example, linear separable. So linear separable, I want to decide that whether the particular student pass or fail. Okay, one student pass or fail. So I have to consider the one parameter, subject mark equal to greater than 50. So 50 is the border. 50 is the border line. I got to make the one line. I represent the line in the 50. So those who are coming above 50, I put it to the pass. those who are coming below 50, I got to put it in the fail. So I can separate with the help of the one line. I can separate the both the classes. So that type of problem normally we call as the linear separable problem. You see in the graph I am giving the diagram. The left hand side I marked so that is a linear separable problem. Okay. So non-linear separable problem. What is the meaning of non-linear separable? You right side you see the XOR gate. So in the XOR gate, what is the input? If both the inputs are 0 or 1, your output is 0. Both are 0 also, output is 0. Both are 1 also, output 0. If any one of the input is 1, then only we can be able to get the 1. Suppose if you want to separate these outputs 0 and 1, I want to separate these outputs 0 and 1 means you cannot able to in single line. In one line you cannot able to separate the output. So your input both the 0 also, your output is you are getting 0. Your both input 1 also you are getting 0. You got my point. Sometimes your model is you have to need the output both your input to features also you got to get the output 0. So both the input 1 also you got to get the output 0. So any one of the input 1 only, then only you can able to get. So these type of problem normally we call as a non-linear separable problem. You see I cannot able to make a single line to separate both the classes. So here you see if I want to separate both the 0 and 1s means I need the two lines. Single line is not possible. That means linear separable is not possible. So these type of problem, non-linear separable problem. So your deep learning concept is mainly used for this one. Okay. So this is the one. I will firstly tell you the CNN and RNN because in one concept itself it will take a more time. Your CNN and RNN and others. So I will just give some idea about the CNN and RNN. If anybody wants to learn more about the thing means you let me know. Later we will discuss also. So it is one of the actually deep learning is your upcoming machine learning. This is the one most dominant. Most of the problems nowadays we are using based on the deep learning only. Okay. So your deep learning is mainly used for the CNN. CNN is mainly used for the image analytics. Okay. For image processing, your input data is the image. If you want to classify the image. So both things are there. Your RNN is mainly used for the time series analytics. RNN is mainly used for the time series analytics. Whereas your CNN is mainly used for the image classification. That means the image analytics. So normally everybody, those who are strong in the image processing, they may know that. So color image and another one is a gray, black and image. Okay. If your color image, we have to represent the three frames are required. One is the RGB, red RGB. So you know the concept of RGB. So color image is represented with the help of the 3 frames. One is the R, another one is the G, and another one is the B. Okay. So 3 frame is required for representing the one color image. Correct. Suppose you see, already I told you in that your neural in the network means each layer is each input is one of the features. Is correct. Each input is one of the features. Your X1 is nothing but one of the feature of the image. X2 is nothing but another one feature of the image. Suppose if you are normally you are giving that input, you are straight away you are getting that extracting the features and directly giving to that particular neural network concept means you imagine that like below one diagram I mentioned that the pixel size 1 pixel 1000 into 1000. Okay, the pixel size is 1000 into 1000 row pixels and similarly 1000 column 1000 into 1000 pixels. So this is the after my input image. My input is size of the image is like that. So this image now I am giving to the my neural network concept. You imagine that how many input features is required. So 1000 into 1000 into 3. So the 3 is represent your RGB. So you imagine that almost 3 billion input is required. Then in the layer in the input side you have to define the 3000 in 3 million neuron node is required for receive the input. So it is a very tedious one. It is definitely it is a very tedious one. So that only we are avoiding this type of network. Normally we call as a fully connected neural network. So that only we got to go for that CNN. For the CNN, no need to extract all the features. From the features, according to the features, first we got to construct. We got to do some steps are there that I will tell you what is the thing is there. So normally everybody know that the image one image is normally represented with the pixel. So the pixel value is 0 to 255. The pixel is 0 to 255. So 255 means full density. The pixel is full dark image. 0 means it is there is a no dot, particular no dot. The value you see here the 8, how I am representing the 8. So this is the number. Numerically I am representing the particular image. So I am giving that image to the input data. So internally it will process that this cell, each cell, we have to get the each pixel value. This pixel is 0. You see the pixel whenever some light density means here you see the value. Suppose 1 again 0 here completely white 0 again little bit dark 11. So wherever we are having the more dark, so it is having the value 255. So wherever you are having the more density value, that point normally we get it marked as a 255. So the value, each pixel value, normally we are representing the 0 to 255. So if you want to normalize the value, means you have to divide. You have to divide 1 by the particular pixel value. Then you have to get the normalized value. All that we cannot use as a 255. You can use the value between the 0 to 1. If you are dividing the particular pixel value by 1 means you can get the value, all the pixel value will be, we got to use as the 0 to 1. That means we are normalizing the value. The CNN, so what are the major operations are there in the CNN means convolution, non-linearity, that is RLU. So here we are using the RLU is the one of the activation function. Another one is the pooling, or we can call the sampling. So flatten. So finally we are using the fully connected net layer. So this is the setup normally we used for in your CNN network. Okay. So this is the setup. Okay. So you see, this is my input image. So this is my input image. So this is the 2. So this is the, actually this diagram will tell you. So this is a handwritten identity classification problem. I am giving the input as a 1 digit. So finally I have to predict that what is the input data. So whether my input image is 0 or 1, 2, 3 up to 9. So output layer will be 0 to 9. So in between we are using, already told you what are the things we are using. Convolution. Along with in each layer we have to use the RLU. Then we have to use the max pooling. Then again it is a so many stages will be there. So finally I am using the fully connected network. Then I am using the flattening layer. So here I am getting the output. So okay, I will tell you what are the things we got to do means. So first already told you. So in the convolution things means here there is no feature extraction. In the machine learning concept, we are extracting the features, whereas in your neural network, we are not extracting the features. So we are extracting the features with the help of that some filters we are using. The convolution step, what we are doing means we are extracting the features. Okay. So you see here, for example, I am giving that image. So image is a 6x6. Here the example I am giving it 28. Maybe here for simple how the convolution process is there means it is a 6x6. So here the value is actually I am giving some numerical number. So normally each pixel is a 256. We got to make it is use of the directly straight away that number, or we got to divide by 1 by 256. We can normalize the things also. Okay. So this is your input image fit. This is your input image, and this is the one of the filter. Okay. We are using the more filter, whether I want to edge sharpening the filter or edge detection filter or sharpening the filters according to what type of features you are going to extract from the particular image. So for that only we are using the filter. So filter will tell you next what type of filters are there. So now the filter we are mapping along to your input image. You see how we are mapping means. So this is your input filter data. Okay. You see the here 301, here 301, 158. 272. So on the top of that, I am plotting that, I am putting that your filter value. That means we are multiplying that value along with your input image value. So after that, what I will get? So the whole, here the 4, all the 9, that means 3x3. The whole value, I multiplied the whole cell, the whole matrix, the whole 3x3 matrix, I multiplied with the filter value. So after that, I am getting the -5. Now you see, I am getting only the -5. That means here the 6x6 input image, now it is 4x4. You see, here your input is 28. So every stage we are reducing. So how you are reducing means now you are getting the 4x4. You see, so this is the one how the convolutional net is using. So next, how it is a one frame. First time plotting. So next I have to shift that one step forward. So you see now next row. Here I am marking the same filter value. Now I am getting the -4. That means I am multiplying all the values. I am getting the multiple. So like that only we are shifting that filter value top of that particular image input pixel value. So that is this type of processing normally we call as a convolutional step. Okay. So these are the different filters normally we are using. So this is your image. So whatever, suppose I want to identify the particular image mean you use the filter value this type, or I want to do the edge detection. So what type of edge use according to you have to use the filter value, whether you have to sharpening the filter. Those who are image processing strong, they may know very well about the filtering concept. So here the simple way is filter is the matrix cell. So that is used for extracting the features from your input image. We are extract because here there is no feature extraction step. The feature extraction step is that filter is mainly used for the extracting the features. What type of features you want to extract, accordingly you got to use the filters. You can use the n number of filters you can use in the CNN network. Okay. Then here you see that feature when we are defining that the network. So we got to define that how many features, how many depth in the sense, how many filters I have to use. So how many pixels I want to move. Whenever we are first 3 cells, again 3 cells. How many 3, we have to moving that filter value, how I have to move. Then another one is the padding. So padding is also one of the important. You see, so after the padding is valid, suppose this is the my input data. I am plotting the 4 filter value. Here you see, here first 4 I am moving the data. Here after that I am having the only one value only. I cannot able to move the next one. Here I am moving these 4. What is the value I am getting? Maximum features, for example, I am getting only the 5. So these 4 cell I am getting the only 11. Here, if I am using the padding as a valid, then you cannot able to consider the last feature, last column value, features value. Suppose I want to consider that value also, then you have to choose the padding option as the same. So if you are using padding option as the same, means you see here you may get to the 11. Here you may get to the among the 4 value, you are getting the maximum 5. These 3, 4 maximum you are getting 6. These 4 you are getting maximum the 11. So that what is the concept here means we are extracting the features, whichever the features are important features, the value, high value represents the important. For example, I want to identify whether the particular number is a digit. Okay. So whenever the digit value is there, that value is the high intensity, high value. That means the high intensity means that value only for importance. I don't want to record the zeros and the less number of value. You see, I want to identify the what is a particular one image means. So wherever the pixel, the image is having the high intensity value, so that features only I have to consider. I don't want to the other features. So for that only we are processing the way like that only. So another is the RLU function. So already I told you RLU is there. What is the non-linear? So it will give the maximum of 0, your input data. So whenever your input image is the negative value, it will not give that. It will not give the output. So whenever the image is having the positive image data, so then only you have to get the output data. You see here before the RLU, your input is having some black data are there. The black. You see that after the output value, so it is having only the non-negative values. So it will remove all the black values. You see only there is no black. There is no black dotted is there. Only the white. That means it will not consider the black value because that is the concept of your RLU function. The pooling step. So pooling is used for the among the features, which features we have to extract, which features we have to extract. So first we are reducing the map. Your input feature image map is reduced. That map is we call as the convolutional map. Using the filter we are reducing. Then that from that map, what are the features, important features I have to extract. Okay, so that is the concept of the pooling step. Pooling is used to extract the important features from the input image. How you are extracting among these 4 value? I am extracting only the 6. Here I am extracting the 8. So here I am extracting 3. Here I am extracting 4. You see your input image is 6 cross 6. Then the convolutional step it is reduced to 4 to 4. Now after the pooling step it is reduced to 2 cross 2. So that means in each step the output of your particular step is the size of your input image is very much reduced because finally we have to map with some very limited number of output layer only we are going to use. So for that only every step we have to reduce the number of that layers. Okay, so and finally we are using one more stage, that is a flattening. So this is the input of the output of the pooling step. So that is we are giving the flattening to the input layer. So here we have to see, so we have to flattening, we have to create the single vector value only. So and finally we have to map to that your input value with the probability of 0 to 1. You see whatever here I am getting the value, so this value should be mapped with the range of 0 to 1 only. So wherever the high probability will be value is there, so that value is the predicted output. So that is the meaning of the soft function. You see here, so this is the output layer. So that means this is the output of the flattening. So the flattening the data. So this is I am giving to the input of the softmax function. You see the value 1.3, 5.1, 2.2, 0.7. So this is the value. So after I am making the value between the range of 0 to 1 only. So wherever the values are highest probability value, so that is the predicted output. For example, you see here where the highest value 5.1 is the highest value. So definitely you see here the value 0.90. Whatever the input your values are there, so we got to map to the range of the 0 to 1 only. So this is the your output probability. So this is the meaning of we are using that your what is it? We can say it is a softmax function. So convolution plus pooling layer as acted as a feature extraction from the input image, while the final we are using fully connected layer. So that is acted as a your classifier. Last layer we are using, here you see the diagram, first diagram. You see after the flattening, so here we are using the fully connected network. Okay, so this setup is used as a classifier. So this setup is used as for consider as a feature extraction, while you are considering our problem as the machine learning problem. Okay, Time is. So these are some of the limitation is there. So we need a huge training data set. We need a huge hardware requirement is there. One important problem is there, a vanishing gradient. This is one of the challenge or the limitation for your deep learning network. So whenever you are adding the more layers, so we have to, because whenever your model is not predicting the proper output, we have to update the weights. Already in the first initial I told you, we have to update the weight and the bias value. So it is very difficult. That is one of the problem. That problem normally is called the vanishing gradient. Okay. So another diagram, so I will not take more time, just to give the idea. What is the role of RNN means? Suppose you want to predict the stock market predict. Okay, you are going to predict the stock market. Okay, that is the stock market prediction. How we have to predict? So you have to consider the yesterday closing value. Normally, when we are considering, we are going to buy a one stock market. Okay, one stock market product you are going to planning to buy. So for that, you have to need the past data also. You cannot, all other neural network, it will consider according to the present data, take the present data, according to the present data, it will give the output. You see, earlier I am giving that image, the input image, whatever the input image, that according to the image, it will classify or predicted. But some of the application problem, I need the reference data, earlier data also. For example, tomorrow I am planning to buy one stock market. So tomorrow opening one value will be there. That is a present day input data. But I don't want to see, I am not able to consider only that data also. I need the yesterday reference also. Is correct. So some of the application, we need the yesterday past output also and the present input also. Today, what is the opening value? Today, what is the opening value of the particular stock product, particular one product? What is the closing value of the yesterday product? I need the both value. After I am analyzing the both only, I can able to whether I have to buy the particular stock is or not. Is correct. So, if I have some application, you need some time series data. That means I need the yesterday past data also, and I need the present data also as an input to my prediction problem. So that type of situation, we have to use the RNN. So RNN problem, recurrent neural network it is mainly used for the time series data and time series kind of problems. Okay. So here, what is the thing means, you see the logic. So this is the final xt is your final output. It is a yt, it is a layer. If one layer I am giving, you see x0 is the input of the present data. I am giving, this is the one cell. Okay, this is the one cell. After it is giving the value to the H0. H0 is the one layer output. That output also I am giving to the next layer. That is a X1. So what is the input of second X1? H0 plus X1. H0 is the output of this one. Is it correct? So this also we are giving, and here also you are giving. So that means I am considering the past data also. You see what is a HT? HT is nothing but present input data. That is your XT. Present input data, then what is it is a previous output data. So both we are giving as an input, then only we are getting the output. So this is that way we are processing that your recurrent neural network. Okay, so in the recurrent neural network is RNN. In the RNN, one important thing is that we are considering the past data. In the past data, so I want to consider some of the data only important. Okay, I don't want to consider all the past data, which of the features are important and which of the features are not important. So that means we are giving some next level of the RNN network. Normally we call as the LSTM. So it is also one of the recent recurrent neural network model. We call as the LSTM model. It is a long short-term memory model. Okay, what is the importance of this model means? So it is also based on the RNN means we are passing the past next the previous data. From the previous data, which of the information is important, whether I have to keep the information or I have to neglect the information. I cannot consider all the past data. Okay, yesterday they are considering all the features, stock market value, the stock, some unnecessary information will be there. I don't want to propagate, I don't want to process consider all the information. So which of the informations are important, which of the informations are not important. So for that only, you see in your RNN, there is no consideration for important information and not so important information. So that is one of the drawbacks. We are considering the past data, but we are not considering that some important as well as the not important information. So for that only, we are using that your LSTM network. So it is the next level of your RNN. So this is that one of the simple view about the LSTM. This is a very interesting concept. It is a recent concept because so here this is a one in the earlier diagram I given the A. So this is nothing but the one A. One A only I marked as a cell. Okay, one A is a marked as cell. In each layer, what are the things are there? I mean, internally we are having the 3 gates are there. Okay, internally we are giving the 3 gates are there. One is the forget gate, another is the input gate, another one is the output gate. So input gate is nothing but we are giving that information. Okay, we are giving that information. What information is new? New information we are giving. The forget gate is used to which information I have to forget or which information I have to pass. Okay, we got forget. Forget means we got to remove, because the concept, important concept of the LSTM is whether I have to keep the information or I have to remove the information. Remove in the sense we are forget. We have to forget the particular. Don't want to forward the some information to the next level. So that means a forget gate. So the forget gate is used to remove the some of the information. So input gate means after forgetting some of the information, we are giving some of the input information, some of the input data also. That input data along with the present input data we are giving to the next level. So next level is we are taking consideration the output. So here the symbol is the activation function. What is here? Here the first you see input stage. It is I am giving that one elaborately. So it is our input hidden state. Hidden state means the earlier state. First earlier state of the output. So under the it is a CT is the cell state. CT is the cell state. So each layer, each cell, it receives the two input. One is a past state, a hidden state, another one is a cell state. Okay, so it is going to the next. It is some cyclic process. So your input state, present state, I am getting the input along with the previous state's hidden information. So both the input is combined together. So here I am mentioning that what is the operation. It is a sigmoid. This symbol is nothing but the sigmoid function. So in the first the input gate, first gate. So what is the first gate? So it is a forget gate. So it is a forget gate processing. I'm elaborately giving the diagram. So the forget gate, what is the output I am giving? So the sigmoid gate is sigma is nothing but the your sigmoid function, sigmoid activation function. What is the input? Your xt comma ht minus t. So after the output ft, ft is the your output of the sigmoid function. That is considered we are multiplying. It is it is nothing but the pointwise multiplied operator. So we are multiplying with this CT minus 1 earlier cell state. So that is passed to the next level. Then your input stage, these are the input stage. The input state we are using that your x state is giving to the your sigmoid function. The here we are getting the IT, and the same thing is I am getting the tan h function. I am getting the CT. So both are multiplied. It is added. So like that the information is processing. So then the output gate is going. So like that the process. It is a huge setup. So here I am giving that what is each layer, what is a forget gate layer. So what is a formula is there. You see forget gate layer. You see one example I am giving. Virat Kohli is a very good batsman. Dhoni is a good wicket keeper. Okay. So first sentence, Virat Kohli is a very good batsman. I full stop. Complete the sentence. So hereafter I am not considering Virat Kohli. Now I am considering what is the present. I am considering only the Dhoni only. I am not considering the Virat Kohli. So I got to forget. I got to forget this data because it is not important. It's correct. First part is not important because second it is full stop is over. Next subject. Because it is a human, it is a machine. How your machine is treated a feature, forget the information, it will consider the subject. So here in the first input data, what is the subject? Your subject is a Virat Kohli. So Virat Kohli is a very good batsman. Subject is over, you make the full stop. You see the current input. Your current input data is you are starting with the subject is a Dhoni. So Dhoni is a good wicket keeper. So you are complete the first subject. You are not using the first subject as a second your input data. So we have to forget the first sentence. That means hereafter we are not considering the information about the Virat Kohli is a very good batsman. You see the second input get data. So here input data you see Virat Kohli is a good batsman. Earlier your data is there. He is a very good fielder. He is an Indian cricketer and he is the current captain of the Indian cricket team. So your input data you have to take all the data because all the informations are all subject related. The subject is continuing. Is correct. So earlier the first here forget in the sense no need to consider the first because subject is over. But here the same subject only we are considering. And what is the output of the gate? So Bob is a very good. He is fighting that. We are giving that. So what is a brave? Brave here doesn't you have the n number of output options are there, but the correct output is here we can substitute the word is a Bob. So this is that some simple sentence as an example I am giving that. So how this layer is processing. So this is a whatever I am giving the example so that the LSTM work how it is working. Okay. So if you are using that TensorFlow, that means deep learning network. If you want to implement the things, so we have to use Keras or TensorFlow or PyTorch also there. So most of the application Keras is best comparing with the TensorFlow because Keras is the higher level library. It is running on the top of the TensorFlow. So that only TensorFlow is important. Okay, so I will go to the things. So time is very running. Okay, already one crossed. So these are some of the recent research topics, whether it is related to your data science also there. But these are some of the upcoming research areas going on. Augmented analytics. So augmented analytics already told you. So AA is mingling. We are using the AA as well as the NLP. We are combining as in the data science that we call as the augmented analytics. So another one is a cyber forensics. So another is the blockchain. So blockchain is one of the current emerging topic. So already you may know that the concept of blockchain. So blockchain, time series analysis, recommender system, edge analytics. Edge analytics in the sense IoT. Edge means IoT devices. IoT analytics. Graph means social media, social network analytics. So NLP processing, behavior analytics, customer buying patterns. So customer orientation kind of analytics is a behavioral kind of analytics. So these are the important analytics field. Most of the things are I concentrated along the data analytics part. So these are the important emerging areas. Okay, so 5 minutes I will wait. Sorry for the. Okay, so here I will share the things. One is that. Hello. Wait 1 minute. I share the the notebook to you, all the notebooks. I am giving the full explanation also thing. Okay. So this is the one of the image classification problem. So this is I am using that CNN network. This is an example for the CNN network. Okay. So this is the image classification problem. Okay. I am using the Keras. Hello, Murugan sir.
Sir, Murugan is speaking, sir. Sir.
Sir, can I take another 5 or 10 minutes?
Yeah, you take, sir. No problem. No problem. We proceed.
Okay.
Okay.
So this is the input data. This data set is openly available in the Keras. In the Keras site, I will tell you where the data is available in the Keras site. So this data set is Keras website. They are providing a lot of the data sets for the CNN as well as the RNN analytics. They are giving the data sets, open source data set. So this is the already how many images are there? You see almost 60,000 images are there and divided in the 10 target classes. So this is a simple example. 10 target classes are there. So what are the classes are there means, for example, frog, car, cat, truck, so lorry, some 10 images are there. So that each image they are having the 60,000 images are there. So using the data set, we can build one model. We can build the model. Then we have to validate the model with the help of the our own data set. Okay. So you see, so this is the important. First, I am using the Keras. So first I have to build the data. I have to input the data set using the Keras flow. So we got to define the Keras flow. Then we got to read the data set. So this is the data set. Okay. So first thing is that we got to import the layers. We got to define the model. So what is your model? What is the model you are going to use? So here I am using the sequential model. Sequential in the model, we are reading the data one by one data and the dense layer. So dense layer is nothing but, so the last layer we are using the fully connected layer. So last part already told you in the CNN network structure. The last layer we are using the CNN layer. So for that only we are using the dense layer, and the dropout method is used for the overfitting the problem. To avoid the overfitting problem, we are using the dropout. Then the flatten, we got to make it is a single dimensional vector data. So that is we are using the flat. Then another thing is that we have to optimize the data. So the further one means, so we got to predict the accuracy. For predicting the accuracy, we got to use one, the loss function will be there. So using that loss function, we got to predict the how much accuracy you are getting. So that means we are using the optimizer. So here so much of optimizers are there. So SG is the stochastic gradient descent method. Add a mass optimizer is there. So much of optimizers method is there. So that is used for to optimize your neural network. So in the sense of you are optimizing the neural network means we are reducing the loss function. So every neural network result is predicted accuracy. So that is we got to error is measured with the help of the loss function. So we got to reduce the loss function, loss rate. Ultimately, we got to increase your predicted output. So that we got to achieve with the help of optimizer function. Okay. So here how many conventional two-dimensional layer? What is already told you what type of max polling we are using. So then here I am reading the data. You see, whatever I am reading the data, I am dividing by 1. So divide the trained data. So okay. So that means we are normalizing the data. We are normalizing the data. So that is the use of the normalize this function. So this is that. So what is the input image? So input image is 32 into 32. It is a color image, so that we are using, you see, 32 into 32, and it is RGB image. So we have to use the 3. And what is the activation function I am using? I am using the activation function RLU. And what is the padding function I am using? I am using the padding function. So whatever theoretically explained, so we got to define what is the padding function, what is RLU, and what is the softmatte function. You see, in the softmatte function, the last dense layer, the dense layer, I am using the softmatte function. So whatever theoretically explained, so everything we got to define. That means we got to construct your neural net, CNN. Okay, so then we got to optimize the model. What is the optimizer we are using? What is the learning rate? Learning rate already we studied. What is the learning rate we got to use? So then we got to train the model. Already you know that the train, we got to divide the data set, then training, test and data set. So epoch means how many times we are running, how many times we are running that, how many we are running the training your model. So that means it will take long time. So then what is the accuracy? What is the accuracy about your model? So okay, so then this is the result. So this is the, I am creating on the symbol one data set. Okay, I am creating on symbol data. Then I validate my model. I am validating the model. I am giving the input image. Okay, I am giving the input image. So one image I am giving the frog. It will predict. You see, F1 is a frog. I downloaded the image. Then I changed it, the image size is 32 to 32 because we defined the model, the frame is 32 into 32 only. So accordingly, I downloaded one image, I resized the image into 32 32 also. Then I predicted the image, so that image is correctly predicted a frog only. But you see, another one model, I given the cat, I given the input image is a cat, but the model is predicting as a dog. So this is the way. So this is a symbol, is nothing but the image classification problem using CNN. Similarly, another one also I can show you. So this is the rainfall prediction. So I want to predict the next 5 days. I am using some 30 days data. Using the 30 days data, I want to predict the next 5 days data means, so each day, one data is required for the another next day. So this is, I have to use the LSTM model. So LSTM, it is a long short-term memory network, already told you. So I defined the model. I am taking the one rainfall data. I am taking the rainfall data. So in the rainfall data, I am taking the 30 days of the data, 30 days rainfall data. Using that 30 days rainfall data, I am going to predict what is the next 5 days data. So this is also, so my real temperature. So real temperature value is the 9.8, 6.2, 0.2, 0 and 0 only. But my predicted the 5 days, it is giving is a huge value. That means my model is giving the more error. Okay, my model is giving the more error. So these type of thing, because why mean I'm taking only the 30 data only. So 30 days data only. If I am taking the more number of data, then we can get the more output also. Okay. Similarly, I will share one more thing also. So this is that, you see, this is so these are the things I downloaded from some of the sites only. Okay, these are the program. So the COVID-19 lockdown period, what is the pollution level in India, especially in the Delhi? So before the lockdown, what is the pollution status? After the lockdown, what is the pollution status? So that also we can analyze the things. Another one notebook also I shared to you. So you see the prediction of images. I already told you same. This is also CNN network. Using the CNN network, whether you are affecting the COVID-19, whether the particular patient, particular input X-ray image, whether the input image is, we got to analyze that whether the guy is having the COVID-19 positive or negative. So this also I have to download the data. This also I will share to you. So I have to download this data set from the Google. So then we have to train the model, importing the library. We got to build the CNN. How many layers are there? What type of RLU function we are using? What is a sigmoid function output we are using? Then we have to train the model, fit the model using the confusion matrix. We got to evaluate confusion matrix. Already we discussed it. Evaluate the model. Okay. So finally, we are giving the input image. So an input image. So this X-ray image is of a negative of COVID-19 patient. So prediction of our model, so that is also negative. Already the result of the model also negative. Your model also predicted as a negative. If you go through the step-by-step line, it is very one. If you understand the one program itself long time, so if you go through all the step-by-step, then you can easily understand. So these are the applications we can go. Your CNN and RNN. So CNN will mostly use for your image classification problem. Okay, whereas your LSTM or your RNN is mostly used for some time series kind of analytics. So these are the some of the applications future we have to use for with the help of the machine learning. Not only the machine learning, the help of the deep learning. So almost 115. So here I will stop my presentation because I think maybe I am a little bit fast only because time is within the 1.5 hours. My intention is I have to cover more. maybe I'm not able to cover all the things. Suppose still if you are having any doubts, means you personally mail me, or yes, mail also, WhatsApp also. Definitely I will share some input data to you according to your research and others.
Okay, sir. Thank you.
Okay, sir. I don't know how I concluded your FDP program.
Sir, we are very happy, sir. We are very happy.
Actually, mine is your last technical session. So my session will give the impact that your whole feedback about your program. Okay.
Yes, sir. Yes, sir. Yes, sir.
Okay.
Okay, sir. Very, very thankful for you.
Even more important to the deep learning. Why means that is more important nowadays. Most application we can use with the help of the deep learning only.
Yes.
So I will share some of the books to you, the deep learning as well as the machine learning, and
Yes,
the statistical learning also more important. And I will share the notebook, your data sheet, as well as the material also I will share to the Murugan sir. You will get it from the Murugan sir.
Okay, sir. Okay. Already you have shared one book, sir. I sent through WhatsApp. Sir.
Yes, sir. Today I will share more 2-3 books are share, sir.
Yeah.
I will share the books. Similarly, I will share the some of the pandas, the machine learning. Suppose some of the participant faculty member they may new for that machine learning. So
Yes.
first to learn some Python's program basic. So don't straight away apply then the deep learning, the CNN RNN network model. You use some of the simple application. Then you can use that high level program. Simple, you start with the simple linear regression problem. Already I discussed one problem, salary and experience prediction. So that type of simple problem, linear regression or decision tree or basic classification, simple kind of basic things first you start to work with. So once you practice very well, then you straight away implement with the high level. So coding and implementation is not a problem.
Okay, sir. Okay,
sir.
You please share all your PPTs.
Yeah, definitely, I will share all the details, sir.
Sir, we are happy, sir. On behalf of IRTT and the management and the principal, I am very happy because you have handled 3 sessions in spite of your busy schedule.
Okay.
Yesterday I spoke. You said that you are already preoccupied with some.
Yes, sir. Summer session and sir, here internal also now the academic class started.
Yeah. They are going to conclude.
Yes, sir. Now 2 o'clock I have our regular MTech students classes. That is also online class only.
I'm very happy.
Arul sir,
I'm very happy. I'm very thankful for you. And on
Okay.
behalf of the participants and the management and IRTT, I'm thankful for you. Soon we will conduct one more FDP. For that also.
Yes, sir. Regarding RN and CNN, you take elaborate manner, sir. Arul sir.
Yes, sir. But sir, CNN itself.
I know, sir. That is very. Yeah.
Okay.
Sir, participants, they are not asking any doubts.
Already in chat box itself, they have asked more questions, sir.
Only one doubt, sir. Only one doubt regarding. Is linear algebra how much important in this that regarding that machine learning applications?
Sir, first the fixing the values. Initially you are predicting that value statistical. So what is the output of the linear algebra? Normally we are using that.
So, right. Zeros and ones we can take that.
Yes, when we are identifying that, what are the independent variables are there? What value we have to get it from that particular values. For that only, the max linear algebra is more important, sir. The question problem, the independent variables value when we are identifying that time that will be more helpful, sir. Linear algebra. The data science mathematically is more important.
So next session you can take elaborate, sir. I need some more doubts regarding that.
Definitely, sir.
Thank you.
Sir, through mail also you ask, sir. Definitely.
Okay, sir. Yeah, thank you, sir.
Sir, he is very good. He will respond through WhatsApp, mail, phone call. He won't hesitate to any doubt. He is kind enough to give all your help. You can fix.
Sir, if I don't know also, definitely I will get it from some of the friends. Definitely I will help you. Suppose
thank you, sir.
He is a very good expert.
It is not up to my level also. Definitely I will help you, sir.
Okay. Thank you, sir.
Thank you, sir. J.Arul Valan, sir.
Okay.
Thank you. I will contact you through phone after finishing the classes. Okay, sir. Okay.
Sir, one participant asking one doubt, sir. The Bhaskar, sir, how can we implement the deep learning, the crowdsourcing? Sir, I didn't understand the meaning of crowdsourcing, sir. What is the meaning of crowdsourcing? I didn't.
I think it is a new word for me also.
Yes, sir. I also first time I'm hearing. Sir, actually, our computer science.
Crowdfunding. No, sir. Alvin, sir. Crowdfunding I heard, but crowdsourcing a new word.
Sir, Bhaskar sir, you mail me. I will get you some idea. I will share to you, sir.
Yes, sir. Sir, please mail because already it is 1:20.
Yes,
Next session,
sir.
madam.
Yes, sir. Yes, sir. Sorry for the sorry for the faculty members.
Crowdfunding. Yeah. He said, sir. Crowdfunding. My word is there. Crowdfunding
Yes, sir.
is there.
Correct. Okay.
Crowdfunding means collecting fund through various sources. I think it's
Sir,
general term.
collecting data.
Yeah. Getting fund from various sources for some work. That is a
Sir,
crowdfunding.
LSTM teach me next time, sir. Definitely, sir. Definitely, sir. So whenever time permits, so I will give more input to the LSTM, sir. So nowadays, LSTM is playing the major of the application we are using LSTM. You can see you can see in the open the Google Scholar also, because most of the other applications we are considering only the present data. So we want to consider the past data, and that data also we got to not consider all the data. Means LSTM will be the one of the very good tool, one of the very good network nowadays. Most of the application we are using.
So next time you spend regarding LSTM, sir.
LSTM, sir. Mostly with one application. Elaborate, we will discuss, sir.
All your
sure.
doubts will be carried out through Valan sir in one FDP. He will conduct more FDP.
Initially,
Murugan sir, next time please allocate that, sir.
Yes, sir. Yes, sir. I will
Yes,
note
sir.
down.
Sir, actually, initially, I also thought maybe some of them maybe repeat also there. Like all the 4 days, some of the expert may discuss some of the things. Whether I am going to repeat the same thing. Initially, I got hesitation also.
Okay, sir. No,
Sir.
sir.
No, sir. Regarding RNN, I expected, sir. But time consumption is very low, so that's why fast. So anyway,
Yes,
no
sir.
problem.
Yes, sir. Yes, sir.
Next time you teach me that. Right?
Definitely, sir. Definitely, sir. Thank you very much, sir. Wish you
Okay,
good luck,
sir.
sir. Sir, wish you good luck to everyone. In
Okay,
future,
sir.
anytime, don't hesitate. Anytime you call me. In the mail also, phone also, immediately will answer. Okay.
Okay, sir. Okay. Thank you,
Okay.
sir. Thank you, sir.
Okay, sir. Wish you good luck, sir. Murugan,
Thank you,
sir.
sir.
Thank you very much, sir.
Thank you, sir. Thank you.
So, thank you for you giving me an opportunity. Thank you very much, sir.
Yeah, sir. Thank you, sir. Very much. Thank you very much. Thank you, sir.